All right, welcome to a pivotal moment in this channel's history. Dun 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 dun. So it's kind of like another moment, like with the JNCIESP, where I scheduled the exam and I took it and I gave a score, whether I passed or failed. We're coming up to another major moment like that right now. So what I'm gonna do is close out the LPIC series, the first exam, um, the final training material in the first exam. So if I go to my channel here and I look at the last video I made, we closed out 104.6. So if I go to the curriculum, we can see the only lesson that remains is 104.7. Now, granted, this is just for half of the exam. It's like the CCNA where you have to pass it, or CCNA from 10 years ago or more, where you have to pass it in two different sections. So the next lesson after this is this how to get certified here, and it's scheduling the exam. I think it's probably through something like Pearson VUE. Yeah, so it's delivered by Pearson VUE. I'll be taking the exam from home, just here in my home office. I just recently did that with the NCORE. I ended up failing that. So yeah. Let's take a look at because we're right at this moment right now where I can actually be scheduling this exam. Let's take a look at some of the dates, the earliest possible dates I can go for. So we're gonna have to go to Pearson VUE, and it looks like we have to sign off on some data policies. Yep. So like the testing policies, they're going to be monitoring. I just took the NCORE, so I'm really familiar with this step. So okay. So now it looks like the next step is to create a web account. I could do that on stream. It looks like there's so it looks like I have to go through a process to obtain a ID. So this might be better served in the next video. This one I think I'll just devote to. Yeah, so I'm gonna stay on topic with this video. That's the next step. I'm getting ahead of myself. First thing I need to do is finish up all the training materials. So let's do it. We've got the very last lesson before I can take the exam, and we'll see if this is an effective study strategy. Here we go. This is 104.7, lesson 1, and the topic is still devices, Linux file systems, file system hierarchy standard. And then the objective is to find system files and place files in the correct location. Alright, so introduction. Linux distributions come in all shapes and sizes, but one thing that most all of them share is that they follow the File System Hierarchy Standard, FHS, which defines a standard layout for the file system, making interoperation and system administration much easier. In this lesson, you will learn more about this standard, which is the FHS standard, the File System Hierarchy Standard, and how to find files on a Linux system. And I'm going to pause it. I want to be on my treadmill for this. Alright, I'm back, so apologize for the background noise, but this just allows me to focus better. Alright, so the File System Hierarchy Standard. The File System Hierarchy Standard, FHS, is an effort by the Linux Foundation to standardize the directory structure and directory contents on Linux systems. Compliance with the standard is not mandatory, but most distributions follow it. Note, those interested in the details of file system organization can read the FHS 3.0 specification, available in multiple formats, at this link. So this is what I've talked about a lot. One of the basic tenets of critical thinking is to know the quality of your sources. Are you looking at a primary source, which is of the highest quality, or a secondary source, or a tertiary source, which is of the lowest quality? So a primary source would be something like this, which are the actual published specifications. So this is really important to have a sense of where this is, what this is. You might think, oh, well, my textbook says it's this way, and my textbook is a primary source, therefore this is the most correct information I can get. Well, educational materials, textbooks, those are secondary sources at best, because you're just drawing from these real-world case studies and this real-world documentation, and those are the primary sources. So it's really important to know the difference between the two, and this looks like an absolute essential primary source to know about. It is beyond the scope of the LPIC, but I think when it comes to like the LPIC-2 or -3, this would be important. Yeah, for now, I think I'm just gonna move on, because this is just a lot. I'll just leave this up for now, but let's keep going. Okay, so according to the standard, the basic directory structure is as follows. // this is the root directory, the topmost directory in the hierarchy. Every other directory is located inside it. A file system is often compared to a tree, so this would be the trunk to which all branches are connected. /bin, essential binaries, available to all users. And I'll need to take a break. I'll be right back. Alright, back to these exciting legendary times in the history of this channel, closing up the last lesson for the first exam of the LPIC-1. Alright, so /bin contains the, and this is the file system hierarchy standards. So we should have an entry here. Yeah, so here's the entry for /bin. This is the primary source, but we're just going to stick to the training materials. So /bin contains the essential binaries available to all users. /boot contains the files needed by the boot process, including the initial RAM disk, init.rd, and the Linux kernel itself. /dev contains device files. These can be either physical devices connected to the system. For example, /dev/sda would be the first SCSI or SATA disk, or virtual devices provided by the kernel. /etc host-specific configuration files. Programs may create subdirectories under /etc to store multiple configuration files if needed. /home. Each user in the system has a home directory to store. Wow, sorry, I'm right outside the window and it's like 5:30 a.m. and somebody's driving very quickly. Alright, so /home. Each user in the directory has a home directory to store personal files and preferences. Most of them are located under /home. Usually the home directory is the same as the username, so the user John would have his directory under /home/John. The exceptions are the superuser root, which has a separate directory /root, and some system users. /lib contains shared libraries needed to boot the operating system and to run binaries under /bin and /sbin. And I forget the difference between /bin and /sbin. Oh, we're going to see it later. So slash bin is essential binaries available to all users, and then slash sbin is something else that we will read about later. So the next one is slash media, user mountable removable media like flash drives, CD and CD-ROM readers, floppy disks, memory cards, and external disks are mounted under here. Slash mnt mount point for temporarily mounted file systems. So that's interesting. I don't know what the difference is between a temporarily mounted file system and and user. Like why do you need? Let me ask the AI about that. That might be insightful. Okay, so the use of slash media and slash mount directories in a Linux file system is a common and practical approach for managing removable media and temporarily mounted file systems. It helps maintain a organized and consistent structure, making it easier for both users and administrators to work with storage devices and mounted file systems. The separation of purposes ensures that removable media can be easily accessed by users, while slash mnt serves as a flexible location for manual mounts. So slash media, this directory is typically used for mounting user mountable removable media, and then slash mount is a more general purpose directory used as a mount point for temporarily mounted file systems. Okay, so why do you need both slash media and slash mount? What is the so when I plug in a USB, why will I need to interact with both of those directories? Okay, so this looks like it's pretty good. So let's get the Morgan Freeman budget. Morgan Freeman, perhaps maybe less than budget, but let's get the read out loud. It's definitely Morgan Freeman. Okay, so it's used for manual mounts. Okay, got it. Got it. So, okay. So is a good of where comes into play. So is a good example of where slash mount comes into play virtualization. Yeah, so if you look at your Windows subsystem for Linux, you'll see slash mount there. So let's, yeah, exactly. Yep. So like WSL is a virtual machine. All right, makes sense to me. So the next one is slash OPT, application software packages. Then slash root, home directory for the super user, root. Slash run, real-time variable data. Slash sbin, so now this is system binaries, whereas bin is essential binaries available for all users. Sbin are, you can almost think of it as like sudo bin or like super user bin. You know, these are the binaries for the whole system, including the ones that you don't want any of your non-system admin users to touch with a 10-foot pole. Those are going to go in sbin instead of bin. The next one is slash srv, which is data served by the system. For example, the pages served by a web server could be stored under slash srv slash www. Then the next standard folder in a file system hierarchy. The next folder that is specified as part of the file system hierarchy standard is slash tmp, which temporary files go into. Then slash usr, read-only user data, including data needed by some secondary utilities and applications. Slash proc, virtual file system containing data related to running processes. Slash var, variable data written during system operation, including print queue, log data, mailboxes, temporary files, browser cache, etc. Keep in mind that some of these directories, like slash etsy, slash user, and slash var, contain a whole hierarchy of subdirectories under them. And those are probably standardized as well. Let's just take a look at slash etsy and see if some of these hierarchies are in the primary source here. So here's /etc, which is host-specific system configuration. So now we have /opt /x11. So we do have some there. I do notice that /opt existed as one of the major ones. Yeah, so here's /opt, but it looks like there's also a /opt under etc. So these are configuration files for /opt, and in /etc/opt, host-specific configuration files for add-on application packages must be installed here, where the subdirectory you installed them, so they all go in one directory, and the directory is the name of the subtree in /opt, where the static data from the package is stored. So /opt is just for your, meat and potatoes, heavy, non-changing static data for your programs. And then any configuration files, custom configurations, data generated from the usage of the program, that goes in /etc/opt, which makes sense because etc is for host-specific system configuration. Alright, so next section is the temporary files. Temporary files are used by programs to store data that are only needed for a short time. This can be the data of running processes, crash logs, scratch files from an autosave, intermediary files used during a file conversion, cache files, and such. Location of temporary files. Version 3.0 of the file system hierarchy standard, which I have up right here, defines standard locations for temporary files on Linux systems. Each location has a different purpose and behavior, and it is recommended that developers follow the conventions set by the FHS when writing temporary data to disk. Okay, so let's look at temporary. Okay, so we've got two hits here for the word temporary. The first is /tmp, and I think the purpose is here, so this links to the same thing. And then we've got one more hit here, which is var temp. So looks like there's two locations. So /tmp okay, interesting. Alright, so let's read more about it in the training materials. /tmp. According to the FHS, programs should not assume that files written here will be preserved between invocations of a program. It is the recommendation is that this directory be cleared, all files erased during system boot up, although this is not mandatory. /var/temp, another location for temporary files, but this one should not be cleared during system boot up. Okay, interesting. Files here will usually persist between reboots. That's interesting. So like an example of that I could think of is like a startup config on a router. That's kind of a temporary file, because the moment you make a change, the moment you're going to have a new startup config, unless you don't want to preserve those changes across boot ups. So like this would be where you would want a startup config to be, and then here this would be where you want just a one-off configuration file that you want to lose for whatever reason. Alright, so the next standard location for temporary files on Linux systems is /run. This directory contains runtime variable data used by running processes, such as process identifier files, .pid. Programs that need more than one runtime file may create subdirectories here. This location must be cleared during system boot up. The purpose of this directory was once served by /var/run, and on some systems /var/run may be a symbolic link to /run. Note that there is nothing which prevents a program from creating temporary files elsewhere on the system, but it is good practice to respect the conventions set by FHS. Yeah, and this is the kind of thing, like when I do my own development, this is the missing piece of the puzzle. So like if you're programming things in Python, this is what you need to know, or like any language, because you know, if you're creating things in Linux and you're doing it in the wrong files, it's just going to be harder than it needs to be. So be aware of these standards. I'll probably even include this in the description to this video, and just you know, use each folder for what it's intended for. So like, for example, if you're going to pull down Ansible source code, put it in /user/source. If you want to make changes to Ansible in the configuration, then put that in /etc/opt. And then if you want to view temporary results from Ansible, like pull downs and stuff, put that in /var. And I think I see that. Yeah, so don't put it in /temp, because you'll lose it, unless you're okay with losing it between reboots. So if you just want to see a quick runoff result, there you go. But if you want to actually collect information and have it preserve across reboots, but it's just temporary, you know, a show run here and now, and you'll see the next one later. Don't really care that much about this one. You got the backup on an official server or whatever. That would be /var/tmp. So, yep, right here. Alright, so finding files. To search for files on a Linux system, you can use the find command. This is a very powerful tool full of parameters that can suit its behavior and modify output exactly to your needs. To start, find needs two arguments: a starting point and what to look for. For example, to search for all files in the current directory and subdirectories whose name ends in .jpg, you can use find, and then remember what this means. So if you do the ls-a, you see this showing up. So this is a self-referential. So it means find in this present working directory anything named, and then we have a glob character, so it can be any character, and then .jpg. And then we've got single quotes here, so it's I thought the single quotes meant that it was literal, so it would be finding a literal like that, but I think I'm confused about that. You know what? I think what this might mean is that this is interpreted as literal because this is a known glob character. Maybe this is not a glob character. I don't know. I don't think it's that important to get it exactly right in that regard. So here we go. Let's try it out in the home lab. Okay, and see we've got so we've got a few matches here. Now, it's interesting that it searches through the subdirectories as well. That looks like that's the default behavior. Now, if you want to get rid of these annoying messages, permission denied, so that's standard error. There was an error message there. So what you can do is you can redirect the standard error, which is 2 to dev null. And now you can see we don't get that permission denied message anymore. Alright, so this will match for any file whose last 4 characters of the name are .jpg, no matter what comes before it, as asterisk is a wildcard for anything. However, see what happens if another asterisk is added at the end of the pattern. So here we go, there's another one. So now we're searching for anything after. So .zip comes after, so we've got an extra result there. The file pentaro.jpg.zip, highlighted above, was not included in the previous listing because even if it contains .jpg on its name, it did not match the pattern as there were extra characters after it. The new pattern means anything .jpg anything, so it matches. Tip: keep in mind that the dash name parameter is case sensitive. If you wish to do a case insensitive search, use dash iname instead of name. So insensitive name instead of dash name. The asterisk.jpg expression must be placed inside single quotes. Okay, this is what I was wondering. To avoid the shell from interpreting the pattern itself. Try without the quotes to see what happens. Alright, so let's try it without the quotes to see what happens. And we can't redirect the error because we should get an error. We want to see that error. Okay, so it looks like it still works. By default, find will begin at the starting point and descend through any subdirectories and subdirectories of those subdirectories found. You can restrict this behavior with dash max depth n parameters, where n is the maximum number of levels. To search only the current directory, you would use dash max depth 1. Suppose you have the following directory structure. Okay, so we've got a directory, and then we've got the soft link here, some directory, another directory. To search inside some directory, you would need to use dash max depth 2, the current directory plus 1 level down. To search inside another dir, which is right here, dash max depth 3 would be needed, the current directory plus 2 levels down. So remember that it includes the current directory. The parameter dash min depth n works in the opposite way, searching only in directories at least n levels down. Alright, so before I read the next section, let me play around with this a little bit. So we're going to go into the directory I made last time, so the permissions lessons directory. Oh, you know what? Which one is it? Documents. There we go. So now if we do tree on that, nothing's in the interesting. Oh, this is the find command we're learning about. So you can use the find command. They're using something like tree to print that out that way, but the find command has these max depths, so we can do a find dash max depth 2, here, and then let's search for .txt. Okay, so it looks like paths must precede the expression. So it looks like the options come after you give it the place to search. Oh. Okay, here we go. So it looks like you have to put it at the end. That's important. So let's move one of these. Let's move clients into dir. So we're going to do move clients sum dir. Let's go into sum dir and we'll do a mk dir, another dir, and then touch another file.txt, and we'll put that in another dir. Okay. Okay, so there we go. So notice how we don't have oh, I forgot the wildcard character, so there just aren't any match. Wait, what? Oh, I see. I got them flipped, actually. So I need to have what I'm searching for, and then where I'm searching. Wait, what? Find. All right, this is working kind of. I'm not sure what's going on here, but it seems to be working okay because we are finding. We are getting the some dir in there. So we are matching on the directories for some reason. Let me try the min depth. Okay, so the min depth does work the way I thought it was. So that means that you can't search for any file except something that's at minimum 3 nested directories deep. So that's good. I just wanted to confirm that it worked that way, and it does. That'd be a good way to filter out the results. Okay, so slash the dash mount parameter can be used to avoid find going down inside mounted file systems. You can also restrict the search to specific file system types using the dash fs type, file system type parameter. So find slash mnt dash fs type exfat, so that's a file system type is exfat. And I think my belt is a little bit out of alignment here. Okay, there we go. Okay, so yep, so exfat dash iname, so case insensitive, and then we're gonna search for any character, then report, and then any character after. So that would only search inside exfat file systems mounted under /mount. Okay, so searching for attributes. You can now use the parameters below to search for files with specific attributes, like ones that are writable by your user and have a specific set of permissions or are of a certain size. So /username matches files owned by the user username. Dash group name matches files owned by the group name. Dash readable matches files that are readable by the current user. Dash writable matches files that are writable by the current user. Dash executable matches files that are executable by the current user. In the case of directories, this will match any directory that the user can enter, X permission. Okay, so these are you can search for permissions, which is pretty cool. Okay, then the next one, dash perm n, so 4 numbers in a row. This will match any numbers that have exactly the NNNN modular permission. So for example, dash perm, which doesn't have any special permissions. And then for the user, it has a value of 6, so that means it has read and write. Same thing for the group, but for the for everyone else, it only has read, it does not have write. It will match any files which the user and group can read and write to, and which others can read to, or RW dash, RW dash, R dash dash. So I got that right there. You can add a dash before those modular permission numbers, 4 of them, to check for files that have at least the permission specified. For example, dash perm dash 644 would match files that have at least 644 RW dash, R dash dash, R dash dash permissions. This includes a file with 644 RW dash, RW dash, R dash dash, or even 774. Okay, so this you can have it be, so if you have a dash perm and then you just feed it the numbers, then it will match those specifically, or you can do a dash, which would means if there are higher modular numbers for each permission settings, which means that there would be more permissions, you will match on ones that have more permissions as well as the ones that match the specific modular permissions number that you give it. So for example, dash perm dash 644 would match files that have at least 644 permissions. This includes a file with 644 RW dash, RW dash, R dash dash, or even 755 since each number is greater. RWX dash R dash, wait, RWX. Oh, there's a typo here. So for the user, the permissions are read, write, and execute. For the group, the permissions are read, write, and execute. And then for others, there's a typo here. One of these characters is incorrect. And now it looks like 775, so that would be the 4-bit on and the 1-bit on. So it looks like this character here is the extra character that is a typo in this training material. So if you remove this character, then there's no longer an error, a typo here in the training material. Alright, so /empty will match empty files and directories. /size n will match any files of n size, where n by default is a number of 512 byte blocks. You can add suffixes to n for other units. N, C will count, so this is a suffix, prefix goes before, suffix comes after, so we're adding the suffix C, and it will count the size in bytes. K suffix in kilobytes, which is not kilobytes, which is not kilobits, it's kilobytes. So K-I capital B. So capital K, lowercase I, capital B means that it's multiples of 1024 bytes. You can also add a suffix of capital M, which is megabytes. So M-I-B, multiples of 1024 times 1024, and N, so the size of N, so whatever size you give it, and then suffixed by capital G for GB bytes, so that's GIB, multiples of 1024 times 1024 times 1024. Alright, so again, you can add the plus or minus prefixes, meaning here bigger than or smaller than, to search for relative sizes. For example, dash size dash 10M, so that's megabytes, will match any file less than 10 megabytes in size. For example, to search for files under your home directory which contain the case-insensitive pattern report in any part of the name, have 0644 permissions, have been accessed 10 days ago, and which size is at least 1 megabyte. And notice how there's a lowercase b. I think that's an error as well. It has to be an uppercase. Otherwise, this probably stands for a mebiobit. I don't know if that's a thing, but this is the kind of thing that I don't like to just let go. If you're watching this channel, make sure that you get things like this right, because it's just, it's like typing a word incorrect. It's that important, in my opinion. So you could use find and then the home directory dash a case insensitive name, any character report, any character after, minus sign perm matching exactly because there's no plus or minus here, 0644, and then dash a time 10, and then size plus 1 megabyte. So anything greater than 1 megabyte. Okay, so this is a pretty long one, so I think I'm going to break it into 2 parts, or at the very least just sit down for a bit. This treadmill is pretty effective, but we're at the 45 mark now, so I'm just going to pause it and I'll be back shortly. Alright, I'm back. I'm feeling good. Before I move on, I do want to, and this should be in its own video, so it's just kind of randomly in the middle here, but I want to talk a little bit about just how important health is to overall success. So I believe strongly in preventative measures. Just try to do the best you can to, like, don't smoke, don't drink, that's kind of what I believe in. Like, maybe I want to keep this, because this is about the LPIC, so like I don't want this to be a debate or to be off topic for too long, but I just wanted to share a article that I was pretty inspired by. And of course now it's just completely off the front page, but I shared it on my LinkedIn. If I go down to activity, so it's this body electric series by NPR. They make a pretty interesting claim on it that if you do some physical activity every 25 minutes, even if that physical activity is something really small and light, like just walking on my treadmill, you can negate most of the effects of a sedentary lifestyle just through that little tiny bit of exercise every 25 minutes for 5 minutes. So unfortunately, I can't see where I found this. Maybe I heard it in there, but I wish I could see. Here it is. So 5 minutes of walking every half an hour to offset the harms of sitting. So exercise physiologist pinpointed a gold standard, 5 minutes of walking for every half hour of being sedentary. So what I like to do is, I've got my treadmill now, which is unfortunately a bit expensive, but you can do a few push-ups, you can do body weight exercises, whatever you want to do. Just put the timer on, hit start, and then when it goes off, just do 5 minutes of some kind of workout. I just find I don't want to stop doing what I'm doing every 25 minutes. So like for me, just hopping on a treadmill and keeping going is kind of the best way for me. But you get those 25 minutes like, it's an investment in higher quality attention and time and focus. So I just wanted to take a moment to talk about that, because this is a field. This is very relevant to computer science, computer literacy, because you're going to be sitting in front of a computer all day. If you like doing that, like me, you can end up with some health issues like obesity. I actually have obesity right now. I just love just sitting, lying down in front of a computer all day, every day for hours and hours and hours, and that's just not good for health. So some people love smoking, some people love drinking. Both are very, very bad for your health. I love being sedentary in front of a computer all day. That's bad for your health as well. So I'm doing the best I can to try to offset the negative effects of that. So in 24 minutes, I'm going to just hop on the treadmill for 5 minutes. All right, but let's close out this. Here we're so close. So the next section is searching by time. So besides searching for attributes, you can also perform searches by time, finding files that were accessed, had their attributes changed, or modified during a specific period of time. The parameters are -A. So this is like the So we've got -A, -C, and -M, and then we've got min after each of them, and then the number. So this will match files that have been accessed, had the attributes changed, or were modified, respectively, n minutes ago. So n stands for minutes, and then the A, the C, and the M, respectively, stand for accessed, changed, or modified. And changed and modified are confusing because it seems like it's the same thing. I think changed is like the attributes, so maybe like the permissions, and then modified is like the file, the contents within. So it looks like they're going to. So let's finish up reading this and then have a conversation with the AI. So the next part is -A, same syntax, but now we have time instead of min. So -A for accessed time, and then in minutes. -C for changed time in minutes, and then -M for modified time in minutes. So this will match files that were accessed, had attributes changed, or were modified n times 24 hours ago. So I was wrong when I said minutes for the end. What it stands for is days, so 24 hours ago. So you can do it in minutes by using min, or you can do it in days using time. For -C min n and -C time n, so that has attributes changed, any attribute change will cause a match, including a change in permissions, reading or writing to a file. This makes these parameters especially powerful since practically any operation involving the file will trigger a match. The following example would match any file in the current directory which has been modified less than 24 hours ago and is bigger than 10 mebibytes. So 100 multiples of 1024. All right, so let's see if I have any matches for that in my home lab. So nothing in the home directory. Let's do it in the documents directory. Let's do it in the home directory. All right, so all sorts of stuff. Now these are the fact that I have my GNS server open. So all the image files that I'm using in my project have been modified less than 24 hours ago, and they are big image virtualization files. Okay, so I think I do want to have a. Okay, actually, you know what? I don't think I need to have a conversation with the AI. This right here cleared it up for me. It's just something that's been modified. So actually, you know what? Look, we might as well. Let's have a let's have a conversation with the AI. So we're going to say, regarding the differences between files that have been accessed, files that have had attributes changed, and files that were modified, explain to me more clearly and simply, what the differences. Explain the differences more clearly and simply. Include example use cases of real world situations where one is most obviously the best one to use over the others. All right, so let's get the robot Morgan Freeman.
Certainly.
We'll call him Al Freeman.
Differences between files that have been accessed, files that have had attributes changed, and files that were modified, and provide real-world use cases for each. 1. Files that have been accessed, a time or emit. Definition: these are files that someone has recently opened or viewed. Example use case: suppose you want to find files that have been recently used by a user on a shared server. You could use this to identify which files are actively being worked on. 2. Files that have had attributes changed, time or commit. Definition: these are files that have had changes to their metadata or attributes, such as permissions, ownership, or file location. Example use case: imagine you want to track changes to a configuration file in a system directory. You could use this to monitor when someone alters the permissions or ownership of the file. 3. Files that were modified, dime or min. Definition: these are files where the actual content has been changed, like editing a document or updating code. Example use case: if you're a developer, you might want to find files that have been modified recently in a project directory. This can help you keep track of the most recently edited code files. In summary, use files that have been accessed when you want to know which files have been recently opened or viewed by users. Use files that have had attributes changed when you're interested in tracking changes to file metadata or attributes. Use files that were modified when you need to find files where the content has changed, like when you're looking for recently edited documents or code files. The choice of which option to use depends on your specific needs and what you're trying to accomplish in a real-world scenario.
All right, and my mistake here, the output wasn't being captured, but I fixed that. So let's take a closer look at the real world use cases. So for files that have been accessed, these are files that someone has recently opened or viewed. A example real world use case would be, suppose you want to find files that have been recently used by a user on a shared server. You could use this to identify which files are actively being worked on. Okay, so the next one is files that have had attributes changed. Then that's different from looking at files that have been accessed. So the definition is these are files that have had changes to their metadata or attributes such as permissions, ownership, or file location. So not changes within the file, Well, although I think changes within the file as well, if we read in there as well. So an example use case would be, imagine you want to track changes to a configuration file in a system directory. You could use this to monitor when someone alters the permissions or ownership of the file. Okay, and then this is files that were modified. So definition, these are files where the actual content has been changed, like editing a document or updating code. And an example use case would be, if you're a developer, you might want to find files that have been modified recently in a project directory. This can help you keep track of the most recently edited code files. Okay, so these are just ones that have been accessed. Now I don't know if I agree with these, because I guess what you could do for this is you could see, like, if you're troubleshooting something and you want to see what log file have people been looking at, you could do that, because I think the difference between these is which one are modified. So like, yeah, for this is where I'd say, like, configuration file changes, this would be more useful for that. But I do have a follow-up question, and that is, does attributes changed include changes to file contents? And I believe it does. It said that it did in the training material. Okay, interesting, because it did say in the training material that was the case. It says that reading or writing to the file. So training materials say, training materials I fed to you originally said that attributes changed includes reading or writing to a file. Or writing to a file that practically any operation to a file will trigger a match. Okay, so let's see what it has to say about that. Yeah, so I'm correct. Right. So yeah, it just kind of makes things up sometimes. But it's food for thought. I mean, it's this is what I talked about when it comes to critical thinking. What's a primary source? What's a secondary source? What's a tertiary source? So ChatGPT isn't exactly asking your crazy uncle for opinions, but it is perhaps similar to asking your severely autistic nerdy cousin for opinions. Or just asking yourself if you're watching this channel. So it sorry. So this is food for thought, but I don't think these actually apply. I do like the idea of finding files that have recently been used by a user on a shared server. That's a good idea. Tracking changes to a configuration file, that's a good idea. And then seeing which files have been edited, and then seeing which log files were viewed. So all sorts of real use scenarios you can think of. Let's do this. So name 10 real world scenarios related to this subject matter. I think this is a good use. Good just for brainstorming, AIs are really good for that. So Yeah, security auditing to make sure, yeah, unauthorized access to files, data recovery, last modifier access, yeah, user activity monitoring, make sure people are not trying to access things they're not meant to, log file management. Yeah, that would be the big one for me. Backup strategies, content updates, file cleanup. Yeah, if people aren't using something, you can help free up space. Software development, compliance reporting, and archiving data. So, yeah, the AI, you got to be kind of careful with it, but I find it to be a really invaluable tool. All right, so moving on to the next section, which is using locate and updated B. I'm not sure what the B stands for. Locate and updated B are commands that can be used to quickly find a file matching a given pattern on a Linux system. But unlike find, locate will not search the file system for the pattern. Instead, it looks it up on a database built by running the updated update db, I think is what it stands for, because it's a database. So update db command. This gives you very quick results, but they may be imprecise depending on when the database was last updated. Okay, so you can like make a cache of all your system files, and then just search through that. So like you're not searching through. The search process is more optimized this way, because find does take a long time usually. So this is useful. So the simplest way to use locate. Okay, this is good. I've always wondered about locate because the difference between find and locate is that locate will not search the file system. Instead, it searches a database, kind of like an optimized version of the file system. It searches a database meant to speed up searches and make them faster. So if that database is not updated or does not match your file system, then it will not be very useful. I found locate to be not very useful, and that's why, because you really need to update DB. So we do need a temporary file to be created. We don't have one, so this is what locate would search. The simplest way to use locate is to just give it a pattern to search for. For example, to find every JPEG file on your system, you would use locate JPG. The list of results can be quite lengthy, but it should look like this. All right, so let's give that a try. Locate JPG. Okay, all kinds of stuff. Got humanity mimes. I don't know what that is, if they just kind of mime out donating money but don't actually do it, or I don't know what the deal is with that. So when asked for a JPEG pattern, locate will show anything that contains this pattern, no matter what comes before or after it. You can see an example of this in the file jpeg_specs.doc. So this is kind of a false match here. It's not a JPEG file, it's a doc file. In the listing above, it contains the pattern, but the extension is not JPG. Tip: remember that with locate, you are matching patterns, not file extensions. So the other difference between locate and find is that you're not feeding it the same kind of characters as you do with find. You're not feeding it glob characters. By default, you're just feeding it a series of matching characters. Basically, you have like default asterisks wrapping everything you send to locate. So locate can be a faster way to do it, but it depends. You have to know how to use it specifically. So you have to know the syntax that it is applying to your searches, and then you have to have your database built, and you do that by running the update database command, update db. Okay, so tip, remember that with locate, you are matching patterns, not file extensions. By default, the pattern is case sensitive. This means that files containing .J, P, G would not be shown since the pattern is in lowercase. So we're not going to get a match on this unless we include the -I. To avoid this, pass the -I parameter to locate. Repeating our previous example, okay, now we've given it -I, and now we've got the file that was missing before because .jpg is in uppercase. Even though we fed it lowercase, we have the -I, so the case is insensitive, so we get this match. Note that the file mate1 underscore old.jpg in uppercase in bold above was not present in the previous listing. You can pass multiple patterns to locate, just separate them with spaces. The example below would do a case-insensitive search for any files matching the zip and JPEG patterns. Okay, so locate -I, and then okay, so you can feed it two patterns to match for. We're gonna match on ZIP regardless of the case, and the same with JPG. So this is like an OR, so we're gonna match one or the other. So we can see this does not have JPG in it, none of these have zip in it, but they're still matches because it matches one or the other. When using multiple patterns, you can request locate to show only files that match all of them. This is done with the -A option. The following example would show any file matching the .jpg and the .zip patterns. So locate -A, and now we get pentaro.jpg.zip. Now, one thing that I find kind of interesting is I don't see it up here. I don't know if that's because it didn't. So it's just interesting that I don't see a match for that up here. And I think maybe this was created afterwards or just not a part of this. Like, that's not significant to this. But I would think that you would get this showing up here because it would match one or the other. So one or the other is there. In fact, both of them are there. So I would think that both of them would show up. But I don't see them here. So maybe it's just the files that are in this home directory are different across these two examples. If you wish to count the number of lines that match a given pattern instead of showing their full path, you can use the -C option. For example, to count the number of .jpg files in the system, locate -c.jpg, and there we go. So this is great for like pulling show runs. If you just want to make sure that you're communicating with you're successfully communicating with the number of devices on your network. You have that number of devices, you can do a -C and you say, oh, we got 10 devices here that I wasn't able to successfully reach out to. So these -C parameters come in useful a lot when you use programming for network engineering. One problem with locate is that it only shows entries present in the database generated by update db located in /var/lib/mlocate.db. If the database is outdated, the output could show files that have been deleted since the last time it was updated. One way to avoid this is to add the -E parameter, which will make it check to see if the file still exists before showing it in the output. Of course, this will not solve the problem of files created after the last database update not showing up. For this, you will have to update the database with the command update db. How long this will take will depend on the amount of files on your disk. Okay, so let me read that again. It just kind of didn't register. So one problem with locate is that it only shows entries present in the database generated by update db located in, and we saw that file here. So yeah, var lib And mine was in a different place, so maybe that's part of why it couldn't open it, because I don't have this mlocate there. If the database is outdated, the output could show files that have been deleted since the last time it was updated. One way to and I gotta do 5 minutes on the treadmill, so I'm gonna set up my treadmill and be right back. Alright, I'm back. Health is really important to success, so any preventative measure is definitely worth it. So, especially if it's cost and time effective. Alright, so reading this didn't quite register with me, so I'm going to try it again. If the database is outdated, the output could show files that have been deleted since the last time it was updated. One way to avoid this is to add the -e parameter, which will make it to check to see if the file still exists before showing it on the output. Okay, so you might get some false positives. You might see one of these. If you use locate, that is no longer on the file system. It's just in that cache that you use to search through to make your searches faster. So one thing you can do is you can read a -e and you'll just do a quick check. Does this file still exist? If it doesn't, then it won't include it in the output, even if it's in the database. Of course, this will not solve the problem of files created after the last database update not showing up. For this, you will have to update the database with the command update db. How long this will take will depend on the amount of files on your disk. So it seems kind of. Let me have a conversation with the AI about this. So what I'm gonna say is, this actually looks like really good materials here. Let me just read this whole thing, because this actually looks really good. I'll have it read it out loud.
The content you've provided explains the usage of the locate and updated commands on a Linux system for quickly finding files matching a given pattern. It highlights the differences between locate and find, where locate searches a pre-built database created by updated, making it faster but potentially imprecise if the database is not up to date. Here's an analysis and my opinion. Advantages of locate and updated. 1. Speed. Locate is significantly faster than find because it doesn't search the file system directly. Instead, it relies on the pre-built database, making it ideal for quick searches. 2. Ease of use. Locate is easy to use. You can search for files using simple patterns without specifying a directory. 3. Case sensitivity. While locate is case sensitive by default, you can use the I flag to perform case-insensitive searches. 4. Multiple patterns. You can search for files that match multiple patterns by specifying them with spaces. 5. Counting files. You can count the number of files that match a pattern using the C option. Disadvantages and considerations. 1. Imprecise results. Locate relies on a database that may not always be up to date. If files have been added or deleted after the last database update, they may not be accurately reflected in the search results. 2. Database updates. To address the imprecise results issue, you should regularly update the updated database. However, this process can be time-consuming if you have a large number of files on your system. 3. File existence. By default, locate does not check if the file still exists before displaying it in the output. You can add the E parameter to verify file existence, but this does not solve the problem of new files not showing up. 4. Pattern matching. Locate matches patterns in file names, not file extensions. This means that a pattern may match parts of file names or extensions. In my opinion, locate and updated are valuable tools for quickly finding files on a Linux system, especially when you need fast results for common patterns. However, they are best used for general searches and should be supplemented with tools like find for more precise and up-to-date searches when necessary. Regularly updating the updated database is crucial to ensure the accuracy of results, but this process might be time-consuming on systems with a large number of files.
Alright, so that kind of cleared it up a little bit for me, but not all the way. So the question I have is, what use is it? Because you can just... Okay, so let's get the answer for this.
You raise valid points regarding the speed advantage of locate being potentially negated by the need to update the database. Updated. Here's a more nuanced perspective. One speed advantage. The speed advantage of locate primarily comes into play when you need to perform multiple searches for the same set of files or when you are looking for common files. Once the initial database is built by updated, subsequent searches using locate are indeed faster than using find, which scans the file system every time you execute it.
Yeah, okay.
So, if you frequently search for specific files, locate
like
can be
automation.
faster after the initial database build.
Locate would be better.
To
than
update it
automation.
overhead, however, the drawback is that you have to periodically update the database. Updated. The time taken to update the database can be substantial, especially on systems with a large number of files.
Can you do it just
This
for
overhead can make
specific-
locate less advantageous if you need real-time or up-to-the-minute results. 3 use cases. Locate and updated are more suited for scenarios where you can afford to have slightly outdated results or when you want to quickly locate files that are likely to be present on your system. It's not the best tool for finding files that have been recently created or modified. 4. Always use find. If you prefer always having up-to-date results and need to search for files that have been recently added or modified, then using find may be a more suitable approach. Find directly searches the file system and provides real-time results, but it can be slower, especially for large directory trees. In summary, the choice between locate and find depends on your specific use case and requirements. Locate is advantageous for quick searches of common files once the initial database is built, while find is better for real-time, precise searches. The decision also depends on whether you are willing to invest the time and resources to keep the updated database up to date.
Okay, so the next question is, can you do it... Okay, so it has to be system-wide. It's typically run as system-wide, but it doesn't have built-in functionality, but you can do a workaround, which is pretty awesome. So you can do prune paths, which is pretty cool because you could prune the you can exclude like /etc. So, but you have to have sudo, I guess, to exclude. So give me 5 top real-world use cases to which this subject matter applies. Or give me 6. 6. Tell me 3 where locate makes the most sense, and 3 where find makes the most sense. Yeah, log analysis, I could see this, all of this being really important. Automation too, like using locate in automation probably makes a lot more sense, because what you might need to do with automation is do a bunch of searches, like 20, 30, 40, 100 different searches. In that case, I use find for each of them. It's going to take forever. If you use locate for each of them, they'll just take really fast. And you can just do one, so I think that makes sense. So here are 6 real-world use cases where the subject matter of locate and find applies, with 3 scenarios where locate makes the most sense and 3 scenarios where find is the most suitable. So for locate, Finding common system files. When you need to quickly locate commonly used file libraries, for example, configuration files, log files that are unlikely to change frequently. This can help you identify system issues or configurations. Searching personal documents, locating personal documents, images, or media files on your local machine. Locate is useful for finding files you know are on your system, such as your own documents or media collections. Server log analysis is probably a big one for server administrators, quickly searching through logs in well-defined directories. For example, /var/log to identify specific entries or errors without having to specify the entire directory path. And then find you would use for precise file searches when you need to perform highly specific searches with complex criteria, such as finding files based on file type, modification size, or owner. Find provides granular control for precise results. Script automation. When scripting or automating tasks that involve file manipulation, find is more suitable. That's interesting. Okay. For dynamically locating files based on specific conditions within scripts or batch processes. Interesting. I guess that makes sense in some cases. I would think that locate would be better because it would be faster. Your script would run faster. Real-time or on-demand searches. When you require up to the minute or real-time search results, especially in situations where files are frequently added, modified, or deleted, Find directly scans the file system, providing current information. In summary, locate is ideal for quickly finding common and stable files on your system or for routine tasks like searching personal documents. On the other hand, find is better suited for situations that demand precise file searches, complex search criteria, or real-time results, especially in scripting and system administration scenarios. The choice between them depends on your specific use case and requirements. So locate is for common and stable files and routine tasks. Find is for precise file searches, complex searches, or real-time results. Alright, still on treadmill. There's basically no limit for how long to be on it, but you shouldn't be off of it for more than 25 minutes, otherwise you'll have those negative sedentary health effects, which is kind of like smoking almost. Alright, so the next section is controlling the behavior of updateDB. The behavior of updateDB can be controlled by the file /etc/updatedb.conf. This is a text file where each line controls one variable. Blank lines are ignored, and lines that start with the hash character are treated as comments. Alright, so prunefs equals any file system types indicated after this parameter will not be scanned by updatedb. The list of types should be separated by spaces, and the types themselves are case insensitive. So NFS and NFS are the same. So the case doesn't matter for pruning the file systems. And then these are the ones you want to exclude in your cache, your optimized proxy for your real files so you can search through them faster. And then you can have multiple with separating by spaces. Alright, so the next one is prune names. This is a space-separated list of directory names that should not be scanned by updatedb. So directory names, and these are file system types. So if you don't want the NFS file system type to go into your cache, so if you have like a temporary, shared file system or virtual file systems, you can exclude that. the whole file system, or like a USB drive, or like if you only want the USB drive, you can exclude your ext file system. And then the names, these are space separated list of directory names that should not be scanned by update DB. Then prune paths equals. This is a list of path names that should be ignored by update DB. The path names must be separated by spaces and specified in the same way they would be shown by update DB. For example, /var/spool space /media. Okay, and then the last one is prune bind mounts. This is a simple yes or no variable. If set to yes, bind mounts, which are directories mounted elsewhere with the mount -- bind command, will be ignored. Alright, so let's take a look and see if this config file is on my lab. Okay, so yep, I've got the config file, I've got yes, we are pruning, so we're not backing up any of the version control files, we're not backing up some of these here, so there's actually quite a bit filtered out, which is kind of interesting. Let me try getting this going again. Let me try a sudo on it. Okay, so that seemed to have worked. It was able to create the temporary file. So let me cat out that temporary file. Okay, and we'll have to do a sudo. Okay, so now it is working. We do have that temporary file. Let's do a less on the temporary file, just so we can get a sense of it. So yeah, we can see all of the cache there. So now let's do a locate, and we'll do locate the JPEG files. And there we go. That was pretty fast. Let's do it with the find command. Same thing we were doing before. So we'll do a pipe grep on it on find. There we go. And then yeah, so we'll do command 1959. So see how that took a little bit longer. So well, it looks like it took the same, if not a little shorter. Yeah, I don't know. Take it or leave it, I guess. Alright, so the next section is finding binaries, manual pages, or source code, which is a very useful command that shows the full path to an executable. For example, if you want to locate the executable for bash, you could use which space bash, and it shows you that it's at /user/bin/bash, which I'm kind of surprised it's not in sbin, because that's like system-wide binary. If the let me ask the AI about that. I'm actually pretty curious about that. So I'm surprised that bash isn't in sbin. Isn't it a system-wide binary, and isn't sbin where system-wide binaries belong? Why is it in bin? Let me get the.
You bring
voice.
up a valid point, and the location of the bash executable is a matter of convention and system design. Traditionally, System-wide binaries that are essential for basic system operation have been placed in directories like /sben or /usr/sben, which are typically reserved for executables used during system boot or repair processes and
Okay,
require
so not
administrative
quite
privileges
this.
to run. However, the placement of binaries can vary between different Unix-like operating systems, and there isn't a strict standard that mandates where every binary should reside. The decision on where to place executables depends on the distribution's maintainers and their design choices. In the case of Bash, it's often found in /bin or /usr/bin because it's a widely used shell by both system administrators and regular users. While it's an important part of the system, it's not restricted to system administration tasks and is used for general user interactions as well. Placing it in a more user-accessible directory like /bin or /usr/bin makes it
Oh,
easily
okay. So
accessible
yeah,
to
you
all
don't
users,
need. It'd be
including
good.
those
So
who may
anything
not
in
have
SBIN,
administrative privileges.
and I can stop it here.
So,
Anything in SBIN will require admin to run. So yeah, you don't want Bash to require admin to run. So that's a clear difference of why you would choose to put something in bin versus in SBIN, because in SBIN you want it to be harder to run. You want it to be more restrictive. So like things like, let's actually take a look at the difference between the things in bin and SBIN. So we're gonna do an ls dash al slash bin. So we can see things like zgrep, bash, I think will be in here. Let's take a look. Yep, bash is in there. And then let's see things in SBIN. Okay, so there's a lot of soft links in SBIN to like virtualization stuff. Looks like there's like mounting things. So yeah, there's things in SBIN that, so like the the file system check. It looks like okay, sorry, Okay, so here's the things that are in SBIN. I think the file system check, was that in SBIN? Yeah, fdisk is in SBIN, so like things like that probably don't need to be doing that unless you're an admin. So like blowing away partitions and stuff, the things could go very, very wrong. The TCP dump is probably in here as well, because that's another. So like anything that's you really shouldn't be using unless you're a system administrator, go in SBIN. Let's see if TCP dump is on the system, because that's a good one. That's like for collecting output that can go into Wireshark. You can do a TCP dump and then you can upload the results into Wireshark, or just look at it as they show out or in files on here. So it's a packet sniffer. All right, so there we go, which is a very useful command. Yep, so we saw that. So this is a good place for bash, because you don't want running bash to require admin privileges. If the -a option is added to the command, the command will show all path names that match the executable. Observe the difference. So, okay, here's the which. So we have this belonging in SBIN, and then if we do the -a, or we have it belonging to user SBIN, if we do the -a, we see it resides in SBIN as well. Tip: to find which directories are in the path, use echo $path in uppercase command. This will print echo. Echo is how you print something. This will print the contents of the variable path to your terminal. Alright, so let's try that in the lab. So we're going to do echo $path. There you go. Type is a similar command which will show information about a binary, including where it is located and its type. Just use type followed by the command name. So type locate. Locate is slash user slash bin slash locate. Let's see where it is on mine. Probably in the same place. Okay, so locate is hashed. That's interesting. The -a parameter works in the same way as in which, showing all path names which all path names that match the executable, like so. So we'll probably see another result there. Let's take a look. Oh, so now we just see. Looks like we don't see that it's hashed when we do the -a. And the -t parameter will show the file type of the command, which can be alias, keyword, function, built-in, or file. For example, type -t, so this would be a file. Let's see what it is in my home lab. Alright, it's also a file. So type -t for LL is an alias, and then type -t for this command type here. Type is a built-in shell command. Do a -a on it. Built-in, yeah. The command where is more versatile, and besides binaries, can also be used to show the location of man pages or even source code for a program if available in your system. Just type where is followed by the binary name. Okay, so this is kind of cool. We can see the source code for some of these commands. So here's the manual page. So yeah, it looks like this is the source code here. So I'm not sure what kind of they're all just links. Okay, so here we go. So this is a shared object. Remember reading about those. So this is, yeah, pretty complicated stuff that we addressed earlier that I'm going to need to know for the test. Okay, so the command where is more versatile, and besides binaries, can also be used to show the location of man pages or even source code for a program if available in your system. Just type where is followed by the binary name. The results above include binaries and compressed manual pages. You can quickly filter the results using command line switches like -b, which will limit them only to the binaries, -m, which will limit them only to the man pages, or -s, these are all lowercase, which will limit them only to the source code. Repeating the example above, you would get -b, which will only show you the binary. So let's follow along with this. So where is locate? There we go. We've got the binary and then the manual page. So let's only see the binary. So we'll do a -b. There we go. And then you can do a -m to only see where the manual page is. And there we go. Alright, so that's it for the reading. I'm going to do the guided exercises and the explorational exercises in another part. I just think that's a very logical way to separate them. Then I'm not trying to just cram it all into one video and not giving them the diligence they are due. Okay, so yep, that's it for this video. Thanks for watching, and see you in the absolute probably last one before I take this test, unless I do some review videos. But yeah, exciting times. So thanks for watching. See you in the next one.